Okay, part two of our capstone activity. You've got your observations, your observed counts for different lengths. So for each observed count, I want you to find the period. Period is the number of seconds for each cycle. How long does each cycle take? So if a cycle goes 1001, 1002, that's 2 seconds. Okay, what would the count be for a minute of those cycles? How would you find the time for a cycle if you know the count? Then, graph the period versus the length. Now we're going to let capital T stand for the period. Period starts with the letter P, but we've already got an important P in the equations here. So we're going to use T. Capital T is going to stand for the time required for a cycle. We're going to usually use a lowercase t if we're measuring time as measured on a clock. Okay, then what do? Having determined this, you do just as we did before with the frequencies. You sketch your curve and you find your y versus x model using all the procedures we've developed so far. And that means, of course, you're going to estimate your value of the y factor, use that to find your exponent p, and then you're going to plug the coordinates of one point on your curve into the model and evaluate the constant a. And you're going to get a model of the form t equals, I'll call it a2 times L to the P2, where P2 is the period you found, and A2 is the value of this constant that you got by using the length and the period on your graph. Okay, then you compare the predictions of your model with your observations in the same way we did previously. Now, I'm not stating all this in all the detail that I did before, but I expect you to understand what those details would be and to do essentially the same thing for this data that you did for the preceding set of data. Okay, that's a good start. Now, this gives us two models. We have a model for frequency versus length, and we have a model for period versus length. Okay, I'll represent those models as F equals A1 to the P1, and T equals A2, A1 times L to the P1, and T as A2 times L to the P2. And A1 and P1, remember P1 is just the period, see I just did it, is just the power P that you got in the first part of this exercise. And A1 is the value of A that you got. So I'm just using A1 and P1 to stand for numbers you already have here, and A2 and P2 to stand for the numbers that you're going to get for the A and the P on this part. Okay, then I want you to take the two graphs you have and use the information on those graphs, just the information on the graphs, on the curves, okay? And when I say on the graphs, I mean on the curves, okay? So let me say, I don't want you to use your data points. Remember, we're done with those once we have the curve. And using the information you can get from those curves, you can use coordinates. You've got a scale now. I want you to construct a graph of F versus T. Now, having done that, I want you to do something else with those two models, okay? When you take these two models here, your model for F versus L and your model for T versus L, this gives you two simultaneous equations. Remember that A1, P1, A2, and P2 are just going to be numbers, so you'd have F as a function of L, and you have T as a function of L. We can treat those as simultaneous equations, two equations, and we actually have three unknowns here, F, L, and T, but we're going to be able to eliminate L and get a single equation that relates F and T using what should be standard algebra 2 techniques for simultaneous equations. Now, you might need a little help with that, and I'll try to provide that in a subsequent video. But what I want you to do is use the equations to eliminate L. Okay, you're going to eliminate L and express T as a function of F. Again, I'll give you a little bit of information on how to do that, especially if that particular aspect of the course was undertaught, or if you haven't even had that material, haven't even had the course that covers that material. It's not that difficult. But if you have had the right courses, remember what you did, you'll understand what this means and you'll know what to do. Okay, then, question I ask, what is the actual relationship between T and F? I say, what's the relationship between T and F really? Okay, really, how is the period related to the frequency? Okay, how is the number of cycles per second related to the, how is the number of seconds required per cycle related to the number of cycles you count in a minute? What it really is the relationship. And how does this really relationship compare with what you got here and what you got here? Okay, this is a pretty profound set of insights. There's a pretty profound set of insights involved in this exercise. And if you can get this, then you really have something that goes well beyond what most people get in a pre-calculus course, even if you haven't already had a pre-calculus course. Something that will benefit you when you do have a pre-calculus course, and if you've had a pre-calculus course, something that will benefit you when you do physics, when you do calculus, when you do more advanced mathematics courses. So I highly recommend this exercise to you.